Hey, what's up everybody? Chris back with another Proto Tech Tip. Now, lately, you may have noticed that we've been talking a lot about bending and looking at considerations when designing with sheet metal in mind. That's because we're going to be putting together an Essentials of Sheet Metal Bending Guide, so stay tuned for that to be released over the next couple of months. But for today, we're going to continue talking about bending and quickly dive back into SolidWorks to show you how to visually validate your models, as well as perform any static simulations that can seriously help with the accuracy and stress analysis of your parts. So, let's just jump in. Now at Protocase and Protospace MFG, we revolutionize your workflow and simplify your part sourcing with the world's fastest custom manufacturing, powered by HVMC, High Velocity Mass Custom Manufacturing. We build your custom sheet metal and machine parts and enclosures in 2 to 3 days, offering a full in-house one-stop shop for materials, components, and finishes. We do make the process of bringing your design ideas to life really simple. If you are not fully proficient in CAD modeling, you can use our in-house CAD design software, Protocase Designer, or download a template from our template generator and import it into your CAD program of choice to further customize, or simply utilize our design services team. But for a lot of you, SolidWorks is going to be the program of choice to design custom parts and enclosures. Now, SolidWorks provides powerful features inside that allows designers to simulate bending operations on sheet metal. Now, these simulations will allow you to visualize and analyze how materials behave when being formed, ensuring that your designs are going to be accurate and, of course, manufacturable. Now, there are going to be a few methods that you can use to perform bending simulations in SolidWorks, tools and features that will help you design with precision and to ensure that no complications happen during manufacturing or during assembly. So the first method we want to look at is using the sheet metal module. The module is specifically designed for working with flat and bent sheet metal parts. While this method doesn't simulate stress and deformation in detail, it's a simple feature that helps create and visualize flattened and formed versions of your sheet metal designs. So let me walk you through those quick steps now. You will first head to File, New, Part, and then use tools like base flange or tab to define the initial sheet metal shape. Then you will use edge flange, sketch bend, or hem features to add bends to your part. Press the Flatten button in the Sheet Metal tab to generate the flat pattern, and review the bend lines and lengths to ensure that everything aligns with your design intent. Now, this method is going to be ideal for quick prototyping rather than performing a detailed stress analysis. But next, let's look at using forming tools for bending. To visualize the bending or forming of sheet metal, you can use the Forming Tools feature inside SolidWorks. So let me show you how that works. First, you will want to go to the Design library and find Forming Tools under the Sheet Metal section. You will want to drag and drop a forming tool onto your sheet metal part. Common tools include lances, bends, and flanges. You will modify the tool's dimensions and angle within the Property Manager. Then use Evaluate tools like Measure to ensure tolerances meet your design needs. Now, this method focuses on the design of formed features to help visually validate your model rather than a complex stress analysis. So lastly, we're going to look at simulations within the static study. The static study in SolidWorks allows you to analyze stresses and deformations caused by bending, giving you good insight into whether your design can handle the applied loads. So let me show you this feature. First, go to the Simulation tab or add the simulation add-in via Tools Add-ins. Now, we want to set up the study. So go to Study Advisor or New Study and select Static Study. You're going to want to right-click on your part and choose Edit Material to assign a material with correct bending properties, for example, steel or aluminum. Use Fixtures to fix certain parts of the sheet metal, and then apply forces or bending loads via the External Loads tool. Click Create Mesh to divide the part into elements for simulation, and then press the Run button to calculate results like stress, strain, and deformation. You're going to want to view the stress plot or deformation plot to check if the part withstands the applied loads. So this method is going to be best for understanding mechanical behavior under much more realistic conditions. Now, if you are designing with SolidWorks and supplement your design process with these methods, you're going to be able to confidently design, analyze, and refine your sheet metal projects in SolidWorks before they get sent to us for high velocity manufacturing. So that's it for today's tech tip inside SolidWorks. It was a quick one, but a super important design consideration. And remember, once you've got your designs ready for a quote, you can drag and drop the file to get an instant quote right from our website, or simply just send it to your account manager. And with that being said, take care until next time.